Hey students, we are going to start our study of Unit 9. And Unit 9 we start looking into statistics and probability. So first of all, statistics. You may have in earlier grades looked for mean, median, mode, range. That's part of statistics. And we're going to explore what those really mean. Before we get started, though, you should have watched a video on Schoology called Clusters, Peaks, and Gaps. If you have not yet watched that video, you need to pause this right now and go back into Schoology and watch that video. All right, let's go on. Okay, to begin with, I do want you to do your bell work for Tuesday. So we are going to just take a look at this. Some of it is a review, and some of it is looking at something that is a little bit new. So let's first of all take a look at number one. Number one is something that's kind of new, where we're going to find each of the unit rates and circle which one is the better by. Now, for our purposes on Bellwork, we're going to allow you to use a calculator. And on this, all I'm going to do to determine how much it is for one, that's what unit rate means right here. It means how much is it for one. We know that 5 of them are $49.95, but how do I find out how much one of them is? So we do that by using division. So in my calculator, I'm going to type in $49.95 and divide it by 5. And I get $9.99. So I know that this is $9.99 for one. And on the other one, we have 33 for $34.95. So I'm going to take $34.95 and divide it by 3. And that is $11.65 for one. So which one is the better buy? Well, the first one is the better buy because it's only $9.99 per one. So not really a difficult thing, but you just have to remember you can use division to do it. Okay, number 2. Okay, so let's take a look at number 2 now. Remember, when we want to use a common factor, we're going to go back to the birthday cake method. So we're going to put 45 and 15 in here. And what number goes into both of those? 5. Goes into this one 9. It goes into this one 3. And then 3 can be taken out of both of those. So 3 goes into that 3 times and that 1 time. So we are really finding quite more than one equivalent expression here. So I'm going to take this top part and put it in parentheses. So 3 plus 1. Then I'm going to take these two numbers and multiply them. And there is my equivalent expression. Pretty simple. That should be a review. Now we are going to find the area of two different triangles here. Now I need to add some lines here so you can see, because the copying didn't work out as well as we would hoped. So we can have that and that. Okay, so again, base times height divided by 2. So pull out the calculator again. I'm going to go 9.4 times 5 and 25 hundredths and divide it by 2. So 9.4 times 5 and 25 hundredths, enter, divided by 2. And I'm going to round this one. I'm going to go 24.7. I'll round to the nearest tenth. And that's meters squared, by the way. Okay, so that's the first one. Let's do the second one. 6 and 7 tenths. Well, actually, 11 and 2 tenths times 6 and 7 tenths. Divided by 2. So here we go. 11 and 2 tenths times 6.7 divided by 2. Again, I'm going to round it to the nearest tenth. 37 and 5 tenths meters squared. Okay, so there's your bell work. Not too difficult, hopefully, for you. And let's move on. Okay, since we are starting a new unit, you're going to be exposed to some words that you may or may not know the meaning of. I added this little vocabulary thing in here to kind of help us out with some of the words. So let's take a look at this a little bit closer. You can see that we're going to be using dot plots today. And dot plots are just taking data. Data is just information, okay? So let's just read this together and see what it says. It says the dot plot uses a number line to show the number of times each value in a data set occurs. Now, a data set is just all of your numbers that you're dealing with. Dot plots or line plots show clusters, peaks, and gaps in a data set. You can also use a dot plot to identify the shape of a distribution. So this is a uniform distribution. You can see that everything's pretty close to being even. If it's even, it's uniform. Symmetric means that it has a good peak in the middle. Now I'm going to draw kind of what the outline of this is. So it starts here and it goes up and then it comes down. So that's symmetric. Now, you can see that this one is not symmetric, the next one. It's called skewed. So you can see that most of my data is over here and then it comes down like this. So if you drew the tops of those, it looks like that. So you can see that the data is skewed when you look at it compared to the symmetric. So you can see that where they call that part that goes down the tail. So this would be the tail extends either left or right. A distribution is skewed left when most of the data is on the right. So all the data is on the right. Wherever the tail is, it's skewed that way. So this is skewed left. That's a concept that a lot of students struggle with. You look at the tail. If it's on the left-hand side, then the data it's skewed to the right. Okay? So those are some of the things that you'll be dealing with today. Let's take a look at a couple of other things here. Here's an example. This example, the table shows the ages of volunteers participating in a park cleanup. Draw a dot plot that represents the data and describe the distribution. So we collected all the ages of these people that are participating, and now we are going to plot it on this graph. And so you can see what they did is they took that 19 and put a dot, 17 put a dot, 18, and they filled in on a number line a dot plot. Now it says draw a number line that includes at least the least value. So I'm showing you how to draw that number line. And the greatest was 21. So you have to make your line represent what your data has. And then we have a peak that occurs at 17, where the most of the data is the peak. And you can see 17-year-olds, they were the most represented in this dot plot. The data on the right of the distribution are approximately a mirror image of the data on the left, so the distribution is symmetric. So you can see it kind of goes down on both sides, so it's symmetric. Okay. Let's take a look at this one. It says draw a dot plot, then represent the data. Okay, so there's all our data. There's our dot plot. And then we can see a peak occurs at 2, and the distribution is skewed right, because look at that. The tail is over here, so all of my data is over here, so it's skewed to the right. So again, there they are. We can see that we've put our data on the dot plot. This would be uniform because they're all the same. This one right here, we can see all of the data is right here. And there are 2 clusters. We have it right here and right here. The peaks occur at 73 and 79 because they're tied, that you can have more than one peak. There is a gap in between 74 and 78 where there's no data. And the distribution is symmetric because it's the same over here as it is over here, approximately. You can't, very seldom when you're doing things in the real world are things exactly the same on both sides. So we kind of have to say, oh, it's symmetric for the most part, okay? So hopefully this little notes page that I threw in here helps you to kind of be ready for some of the vocabulary that we're going to be dealing with as we do your practice and we do your assignment. Okay, so here is your practice. I'm going to go over it with you. And this one's kind of a puzzle, so it's kind of fun. So it says, write the letter of each answer in the box containing the exercise number. Determine whether the question is statistical or not. Now, that's something that we haven't talked about yet today, and that's why we're going over it right now. As statistical questions are questions that have various and multiple answers. So if I asked, what is your favorite color? Is that a statistical question? No, because I'm asking that to one person and they have a favorite color. I only get one answer back. So it's not statistical. But if I said, what are the favorite colors of Mr. Roberts' math classes? That's a statistical question because there's lots of different answers I can get back from that. So that's what we're looking at right now. Number one, how many hours do sixth graders spend watching television on the weekend? Is that statistical? Am I getting more than one answer back if I ask that question? Yes, it is. Number two, how many states begin with the letter A? Okay. How many are there more than one? Alabama, Arkansas, there's other ones, Arizona. So yeah, I'm getting back various answers. So yes. Number three, how many members is in the sixth grade households have cell phones? How many members in the sixth graders households have cell phones? Am I going to get back different answers for that? Yeah, I am. So now we are moving on to something that we've talked about already. Display the following data in a dot plot, then use the dot plot to answer the questions. So I'm going to pause right now and then draw the dot plot. And then after you see the dot plot, you hit pause and then copy it. Okay, so there is your dot plot right there. So it says identify the peak. So do we have a peak at 25, 24, or none? Well, we can see that the most data represented on this dot plot is at 24. So we have 24. So identify the cluster. So do we have a cluster around 24 or do we have a cluster around 31? So a cluster is where is most of my data. Most of my data is around 24. And then identify the gap. So do we have a gap right here. In between here and here. So we have a gap in between 27 and 31. All right, guys, I want to go back up to number 2 really quick. Number 2, I made a mistake. How many states begin with the letter A? That is not varied. Yes, there are more than one, but you have to ask yourself this question. Is there more than one answer? And can there be varied answer? This one, there's not a varied answer. It's finite. If I ask how many states begin with the letter A, okay, we're going to have, and it's going to always be the same. There's one answer to that. I kind of messed that up, so I apologize for that. So my answer on this one is E, and that makes our little puzzle down at the bottom it makes it a bagel. Now let's look at what it says. If a seagull flies over the sea, what flies over the bay? A bagel. Kind of fun. All right, let's move on to your assignment now. Okay, so here's your assignment. It wants you to do a couple of things here. Identify any cluster. Oh, first of all, you have to make your own dot plots for this data. Then identify any clusters. So you're going to put a circle around your clusters. You're going to put a star by your peak, and put a square around your gaps. And you're going to also answer these into Go Formative. So the instructions on how to answer these in Go Formative is there for you to look at. So you're going to do that for all 3 of those. And then number 4, the dot plot shows speeds of pitches in baseball. And you're going to look at how many pitches are represented, and then write a statistical question that you can answer using the dot plot. So there you go, guys. That's your assignment. Good luck. If you have questions, ask your teacher.